Right, good morning, AP Calc BC. Another day of online learning. Thanks for your toughness this week and sticking with it. We have a little bit of Kahoot coming up today, so I hope you're excited. But let's turn our direction to the PowerPoint just to kick us off. First, just reminding us of our goal: 30 out of 30 of us are going to score 4 or 5 on the BC exam on May 5th to earn that college credit, Calc 1, Calc 2. Check those off your college transcript. With that, here's our agenda for today. Oh, looks like some things disappeared. Video, we're going to do a quick exit ticket review, follow up on the exit ticket questions, review some integral rules, and then learn how to Kahoot from home. This will allow everybody to be ready content-wise, making sure they know their integral rules, and also know how to connect to Kahoot so we don't have to waste any time with people setting up their phone, mobile devices, Chromebook, whatever you choose to use. With that, then our Zoom call is going to be just a remote Kahoot competition to close out this first week of online learning. So I hope you're excited. I know many of you asked about Kahoot this year. Today's the day, so here we go. Exit tickets submitted on time. We had 29 out of 30. You see your name up here. You were part of that 29 to have your exit ticket submitted. Thank you for doing that. 2 quick shout outs to Sade and Bianca. They popped in the office hours to get some extra help, and I hope they benefited from that. You can too. Pay attention to classroom for when those will be. Integral test exit ticket review. Question 1 looked pretty great. We had 26 out of 29 people put A. That is correct. Notice how the lower limit's 1, the upper limit's infinity, and then we just swapped out the letter N for the variable X. Be careful if you chose D. It's not an X in the denominator, it's an N in the denominator. And then in part C, we have not taken the antiderivative or derivative yet. We want to just translate it to an integral first. First question was Amanda's question. To clarify, the integral test is just a combination of everything we've learned about series tests or just what we've learned the past 2 days. So really good question. Essentially, yes. First, we had to learn improper integrals on Tuesday and Wednesday. So that was kind of new content, but then we brought that together with the integral test on Thursday. So you can think about the integral test as another tool in your arsenal, Amanda, to determine if a series converges or diverges. I totally recognize that we need more practice with putting all the tests together, and we'll do that. This is the last test that you learn, so give yourself a pat on the back for getting through our last test. With that, question 2, correct answer was C. We had 28 out of 29 people choose C, and then when I was reviewing with a few other students, this is actually on the classwork. So if you did well on the classwork, you got this question right as well. Great job with that. Question from Paul was, is getting positive infinity as the answer after the integral test the same as getting undefined? Interesting question. You sometimes will get undefined, Paul. You sometimes will get infinity. But look at my response for how those connect. When evaluating definite integral, if you evaluate the limit and get either infinity or you get undefined, either one tells you that the integral diverges. So sometimes you'll get infinity, sometimes you'll get undefined, depending on the functions involved. But both those allow you to conclude that the integral diverges. With that, on to question 3. Correct answer was D. So correct answer was D, and let's find out why. The series does converge, and we'll see that the integral converges as well. So I'm going to flip to the doc cam for us to see how this one works. So follow me over there. So same prompt, starting with this series here. Based off our work yesterday, I know we're pretty good at choosing what the integral should be that we compare this with. So this will be integral from 1 to infinity, x e to the negative x squared dx. Great, and so when I look at this integral, first thing I'm going to do is rewrite it with a limit as t goes to infinity for that upper limit 1 to t, x e to the negative x squared dx. And then similar to what I did yesterday in the Zoom session, we're going to use u substitution to find the antiderivative of this. So u will equal negative x squared du would equal negative 2x dx. I could replace negative x squared for my exponent up here, but then I have only x and dx hanging around in the integrand. So we need to move the -2 to the left so that I get this. Now this part matches this and this. This allows me to rewrite that integral as integral e to the u times du over -2. And when I take that antiderivative, I get -1/2 e to the u plus c, which equals -1/2 e to the -x squared plus c. That was the u substitution work we had to do, kind of on the side. And then from here, we can pick up our work, limit as t approaches infinity, integral from 1 to t, -1/2 e to the -x squared dx. It's a definite integral, so I'm going to drop that plus c. Then from there, limit as t approaches infinity. Actually, I have the antiderivative here. Sorry, quick typo. This shouldn't be here. This shouldn't be here. This shouldn't be here. This should just be like this. Sorry about that. So we have this. Now we can plug in our upper lower limits, and we get -1/2 e to the -t squared minus -1/2 e to the -1 squared. Put that in parentheses. Great, so now I can evaluate my limit. And so when I take the limit of this component, t is going to infinity. So this exponent, t, is going to infinity, but the entire exponent will then be going to -infinity, because that negative on the outside. So if that goes to -infinity, that's going to make this whole term go to 0, like this. Then this next part is just going to remain what it is, plus 1/2 e to the +1 because it's being squared. So this would just equal 1/2 e. If you need another breakdown of this, I'm going to break that down here. Breakdown. I could look at this part as the limit as t approaches infinity of -1/2 e to the -t squared. If I just zoom in on that part, I can rewrite this as limit as t approaches infinity of -1 over 2 e to the t squared. And when you look at it this way, if t goes to infinity, that exponent's going to go to infinity, which means the denominator of this fraction is going to go to infinity. And when we know when the denominator gets huge, the whole fraction gets small and goes to 0. So because I get a finite number here, we know the integral converges, and then from there, we know the corresponding series also converges. And with that, that's the work to back up why the integral, why the series converges, and the work behind that. Tough question, made it 1 point, so it didn't crush your eggs to get score, but definitely check that out, replay it if you need to. All right, from there, we know the correct answer now is D. And so we just went through that. I had another couple similar questions from Noah and Samaja. Can we review U-sub integration by parts and those other methods? And then Samaja asked, I just need more review on some of the integral materials such as by parts, U-sub, etc. Thank you for asking, and given that, we're gonna work on that during Kahoot today. We'll do a little bit of review during this video. We'll probably break out into breakout rooms before we start Kahoot, and then we'll dive in. All right, so here we go, integral rules review. Remember, unit 7, we were really strong at. We had like an exit ticket every single day, and you were crushing it when we learned this unit. So we just got to dust off those cobwebs to make sure we are ready to go. So here's your basic integrals rules. I'd recommend you pause the video right now to make sure you have those down. On the next slide, I'm going to cover them up, and you can see if you really got them down. All right, go down the list, see if you can name them all. Watch out for those trig functions on the right. Don't forget your inverse trig on the bottom right. And here are the answers. All right, there they are. Any that you miss, I would star and write those down and add that to your like a flashcard list or something to make sure you get those down. I'm confident all of you can get x squared over 2 plus c. I know the inverse trig functions and some of the trig functions always trip people up. Just got to make sure you memorize them. Got to have them down. Look for patterns to try to memorize them. Helps your brain wire them together so you can more easily remember them. Second part, methods of integration. Here is when to apply them, and then some key formulas you might need to know. I would pause the video, check those out. I have a few check for understanding questions on the next page. So what are the 7 methods of integration for BC? Direct integration, anti-chain rule, simplify, long synthetic division, partial fractions, U-sub, integration by parts. When to use the anti-chain rule? Use the anti-chain rule when the derivative of the inside function, or sorry, when you have an inside function who's linear, when you have an inside function that's linear. So an example of that might be, draw an example on the screen, 1 over, let's say 4x plus 2 to the negative 7. That inside function right here is linear. So that makes this an anti-chain rule question. Don't forget your dx. I know someone at home is saying, Mishkope, forget your dx. All right, then if we consider the next slide, x out of here, U substitution is a little bit different. Think about when you use U substitution. There is a inside function whose derivative is hanging around. So you need an inside function, kind of like the anti-chain rule, but then the derivative of that inside function is hanging around. So we saw an example of that in the exit ticket review. And then here was another example that you might see something similar to. If you have 4x, and then let's say we had times sine of 7x squared plus 2 dx. From here, we would go to, we see that this inside function here, derivative of that would be like 14x, which is kind of like this. And so we get u equals 7x squared plus 2 du equals 14x dx. And then we can do du divided by 14 equals x dx. And we'd substitute from there. We'll have a little bit of review of this with Kahoot, and we'll go from there. All right, and then integration by parts. That's the formulas you got to know for that are integral of udv equals integral v du minus, or sorry, totally messed it up. Integral of udv equals uv minus integral of v du. That's on your reference sheet. You can rewind the video if you need to see that. And then also there's that 5-letter acronym that you got to know. ILATE, inverse trig, logarithmic, algebraic, trigonometric, and exponential. That's the order in which you choose u. That's how you choose u. All right, and so now let me clear these silly annotations out of here. How to Kahoot from home. Just wanted to put this in here so we can jump right into the Kahoot a little bit later, or actually momentarily. So let me get rid of my annotation tool. Gone. How to Kahoot from home. The norms for our Kahoot session are going to be everyone logs in at the beginning. And then as we go through the questions, I'll switch to the next question. Everyone enters their own answer on their device. Once we have the right answer and reveal that, I'll take hands to explain the correct answer. And then we're going to repeat. This is going to be very, very fast practice. And then top 10 scores get a 100% on a classwork from this week. I know I haven't gotten to those classworks yet. Been a lot of adapting to this new online learning. I'm going to look at some of those this weekend. And if your top 10 scores today, you will get a 100% to override one of those classworks. And then how to join Kahoot. Really want you to figure this out on your own so that you can be ready to jump in momentarily on the Zoom call. You can either go to the website or use the Kahoot app, but please use that time now to pick one of those and get set up. And then the code you need to log in, I will give you during the Zoom call. I can't give it to you right now because it changes every time I open up Kahoot. So I'll have that in the Zoom chat so you can jump right in. Some suggested possible setups to make sure you're ready to jump in is if you have a computer and a mobile device, Zoom on the computer and Kahoot app on your mobile device would probably be the best option. Kahoot app's gonna work way better than the browser on your phone. And then having Zoom on the screen will allow you to see the questions. Other options are having Zoom and Kahoot website on your computer. You can just switch between the two to bubble or select your answer. Or I think this will work if you Zoom and use the Kahoot app on your mobile device. Make sure you have the app though, so you can switch between the apps. I think if you do Zoom with the Kahoot website, it might time you out or log you out of the Kahoot website every time you switch, and that would kick you out of the game. I don't want to kick you out of the game. I want you to play the game, and I want you to win. So with that, I'll see you momentarily, and let's see how this Kahoot remote goes. I'll see you in a bit.